Hi all, welcome to part 4 of the video lecture on ER modeling. So previously we gone through what is ER model and what is an entity, what are all different types of attribute or properties of the entities, what we discussed so far. Now let's see some more properties about this ER model. So here let's differentiate between two terminology. What is an entity type and what are all, what do you mean by entity set? So as a name says, or simply you can read this last line, so that explains the entire thing. An entity type describes some kind of schema is otherwise called the intention. Hope you remember this terminology. For a set of entities that share some common structure, so that is entity type, and the actual values, once you populate it with the value, is what we call as the entity set. So it is something like this. Let me take this example and come to that. So for example, I can say that this employee is an entity having attributes name, age and salary, right? So I have an employee entity and the attributes of the employee entity are like name, age and salary, and I have another entity called company, and the attributes of this company entity are like a name of the company, headquarters and president. Okay, so this structure, I mean, there will be a number of employees, there will be a number of company, different company, and their name, headquarter, those things will vary. But the common structure is like this. If I am looking at an employee entity, this is a structure. And this structuring or the schema of that employee entity is what we call as an entity type. Okay. So here you can see that the entity type, I have an entity type employee, and this is the name of the entity type, and these are all the attributes. So together we call it as the entity type. Okay, and this is another entity type. So that is a common terminology. It's a structure. Now what are all the different entities inside this particular entity type? For example, if you are looking, this is a particular entity having name John Smith, age 55 and salary say 80k. This is another entity having name as Fred Brown, age 40 and 30k as a salary, and this is another entity, that is E3. So this collection of entities sharing a common structure, the structure is what we call as the entity type, is we call as the entity set. So entity set is otherwise called a extension, entity type is otherwise called a intension. Okay, so it is intention, NTSION. Okay, yeah, that about it. So hope you get the idea, right? That the common structure and on the collection of entities having that common structure. A database usually contains groups of entities that are similar. For example, a company employ hundreds of employees may want to store similar information concerning each of the employee, and these employee entities share same attribute, but each entity has its own value. That is what we see. The entity type defines a collection of entities that have the same attribute, that common structure. The collection of all entities in having a common structure or entity type is what we call as the entity set or the entity collection. Entity type is otherwise called schema or the structure or the intention. Entity set is otherwise called the extension of the so-called entity type. So it's something like I have an entity type like this. I am extending it with the values. So that is extension or entity set, and this is the common structure of it. So what we call as the intention. Okay, hope the terminology is clear. Similarly, when we define what is relation between two entity, that time we will see what is a relationship type and what about relationship instances, like in a relationship set. Okay, same thing we will see there also. Hope you get the idea, right? So if sometimes they may ask you clearly explain these two terminology, with this example you can explain. Fine. Now this is something I already told you. There is a concept called a key attribute of any entity type. So that is a very special attribute. Let me tell you why it is needed. For example, suppose I have this employee entity type. Okay, and let me keep the attributes of the employee entity. Let it be name. Okay, and there is another attribute called the age, salary. Suppose I am keeping these three information. Now what is the difficulty I am facing? Suppose I have a name of a person as John. Okay, maybe for full name as a small example I am taking, and his age is 55 or some 50, and he is getting a salary of some 50k. Okay, fine. Now is there any possibility that there is a different entity? So this is my first entity. I am concerning about details of a particular person. Okay, now I in the same department, is there any chance that there is one more employee joining and he is also having the same name? Possibilities are there, right? And he is also of same age. Okay, both of them born at the same time, and he is also earning the same salary, maybe of same job. This is possible, right? But now how you are going to differentiate this employee, I mean entity E1 from E2? Actually, we know that this belongs to two different people. But unfortunately, their name, age, and salary, all these attributes are found to be same. So from the database point of view, it's not possible for us to differentiate these two, right? Now what you can do is interesting. You can try to keep a special attribute called the key attribute that is always going to assume a unique value. For example, let me add something called a some identifier, right? Every people are having some unique Aadhaar number, something like that. So in the textbook they are using something called a social security number, which is a unique identification of these people, and we have the guarantee that the social security number of these two people are going to be different if they are different people. So definitely, so this is going to uniquely identify entity E1 from E2 because all other fields are same, but only this SSN is unique. So we need to keep at least one attribute as a key attribute that is going to uniquely define. Let me repeat the term unique. Uniqueness is needed, right? Uniqueness, we call it as uniqueness constraint also. That is going to uniquely differentiate each entity from other entity. So this is something important, otherwise these two field we will assume like when the implementation point of view they are just looking same, so why I have to keep it again and again? I can simply eliminate it, so like that. So and you may be confused, like a particular entity 1, the salary is changed to 50k to 60k, but how you will understand that whether it is entity 1 or entity 2? Because by if I am calling that the person John salary raised then both people you have to raise the salary. Or if I am saying that a person John with age 50 salary is incremented, again it is having repetition, right? But if I am referring to that SSN, definitely it will be different. So that is the power of key attribute. Without that the entire thing is meaningless. So it is mandatory to keep at least one attribute, or maybe a collection of attribute, can be a composite attribute, can be anything, as a key. So that is needed. So that will uniquely identify one entity from the others. So an important constraint on the entities of an entity type is the key attribute or the uniqueness constraint on the attributes. Okay, so this is otherwise called the presence of key attribute is trying to impose the uniqueness constraint. An entity type usually has one or more attribute whose values are distinct for each individual entity in the entity set. It can be one or more attributes. Such an attribute is what we call as the key attribute, just like the SSN. So for example, the name attribute, another example is given in maybe in a company database, name of the company is unique. If that is, but you can't say that the name of a person should be unique, like two people are not supposed to have the same name. So that you can't impose. So here SSN is mandatory. But if you are looking at the department name and all, while constructing, I mean once you give a name, you can make sure that, because a limited number of departments will be there inside a company, right? So that time you can ensure that the company name is going to be unique. So if that is the way you are designing the database, then it is fine, because no two companies are allowed to have the same name. So that is the kind of restriction we are having in the mini world. Then it is okay, name of the company you can keep as the key, but we can't say that two people are not supposed to possess the same name. Such a constraint from the mini world is actually meaningless. So that is why I taken that example. Similarly, a person entity type, a typical key attribute could be the social security number. So that is what I explained. Okay, now another thing is like sometimes this key attribute can be of composite type. So let me tell you an example for that. Here you can see that in a car we have the registration number, right? So this notation you don't worry at this point. So we have this registration number is a attribute of this car, and if you are looking at any registration number, there is some code that says which state it belongs to, and there is some number. And you can see that if you are looking at the state alone, many registration numbers are having common state, right? So all cars from the same state will have the state part alone repeating. But what about the number? Within a state, the number will be unique. Like if you are looking at something, say starting with the KL, you can see that different numbers for that are uniquely given for different way car. Okay, car vehicle. So but if you are looking at some another registration, say T and Tamil Nadu registration, that time if you are looking at the number alone, sometimes there may be two cars, say from KL and TN, having the same number. So that is possible, right? So that means if you are looking at number alone, it may repeat. If you are looking at state alone, definitely it is going to repeat. But if you are looking at state and number together, it's not going to repeat, right? So that is why I am forced to keep this key attribute as a composite attribute. I can't say that state is a key attribute, it's going to be unique. I can't say that the number is unique, because within a state it is unique, but across state it may repeat, right? So all together I can say that state and number together is unique. Okay, so like that I can keep the registration number. And another key attribute for the car is the vehicle ID itself. That is going to be unique for different manufacturers and different vehicles. Okay, so that about it. And suppose an entity is not possessing any key attribute, we typically call it as a weak entity type. We will explore this weak entity type in future videos. So that is of a very special concern in the ER diagram, ER modeling, that we will see. So as of now, what is a weak entity? Weak entity, it is weak in the sense it's not having a key, right? So the elements are going to repeat. Now how you are going to deal with such weak entity? So we typically connect it with some strong entity, and by means of a suitable identifying relationship. So after discussing relationship, we will see this. We will try to relate. So that is a different story. Anyway, as of now, weak entity type is something that is not having a key. Okay, so the normal case we are not going to allow it. So just go through it. Sometimes several attributes together form a key, meaning that, so when you are making several attribute together as a composite key, so the like that car registration number is said to be a key which is composite also. You have to ensure that it is minimal, in the sense that state and number together is not going to repeat. But if you are adding state, number plus say mode, something, make of the car, like in which year it's launched or something, that together is also going to repeat, also not going to repeat, because of that state and number combination, right? So always ensure that this key attribute is going to be minimal. That means if you remove any one of the attribute from that composite thing, if it is still a key, what you removed is something redundant. Okay, anyways, at this point, if you have any confusion on this minimal key and minimal, that part alone we will discuss in our future video. Okay, so at this point you have to ensure that the composite, when you are making a key attribute as composite, try to include minimal number of attributes that together uniquely identifying each entity in that particular entity type. Okay, so I mean, if something is redundant, so typically we call it as superflows, right? If such superflows attributes should not be included in key, they have to be eliminated, right? So you have to ensure that only the minimal number of attributes are there in the composite attribute. So there may be more than one key attribute also for a given entity. For example, that example we saw, like that car example, vehicle ID alone is a key attribute, registration number alone is a key attribute, and vehicle ID is a normal key attribute. Registration number we saw like it's a composite key attribute. Okay, so that is what we see. So now it's about the notation. So already you saw the diagram and all, and now you are okay with the notation. But anyway, this is a time we have to introduce the notations for entity, attribute, relationship, and all other things. Okay, so something we discussed so far, we will see the notation, and future things we will see the notation, and when we are discussing that. Okay, so first of all, how you will be representing an entity type, that is a structure in an ER model. You have to use for representing entity type, you have to use a rectangular box. Okay, so keep that in mind. So that is the first notation we are having. Now to represent the properties of the entity or the attribute, we have to use ovals, the oval shape thing. And the entity and this oval attribute, they are connected by just a straight line. Okay, double line and all, they are having different meaning, we will see that. Composite attribute, typically oval shape, the main composite attribute we will represent, and the sub attribute we will attach to the main one using the straight line. Multi-valued attribute are represented. So here this you can remember, like entities are represented using some rectangular box. Inside that we will write the name of the entities, like so this is an employee entity. Okay, like that. Now the properties are represented by some ovals like this. For example, this employee is having a property that is name of the employee, and the employee entity is having another property that is age of the employee, like that. And another property, say the phone number of the employee, and that time you know that the same employee may possess more than one phone number, so that is a multi-valued attribute. So typically this is a way we are representing multi-valued attribute, that is multi-valued attribute represented in double ovals. Okay, so something like this. Now the key attribute, how will you represent key attribute? For example, for the employee, this social security number is found to be key attribute, and they are represented by an underline. Okay, so if you are seeing any attribute with an underline, say understand that it's a key attribute. Okay, so like that. And let me tell you one more thing. So here itself, if you are looking at the age attribute, okay, so if you are looking at the age attribute, so typically we will store the date of birth, right? So date of birth, it is a valid stored attribute, but age is actually derived from the date of birth, something like that we already seen. Such a derived attributes we will represent like this. So I forgot to add that as a point. So this age is found to be derived as, so dotted oval shape is what we are using for derived attribute. Okay, so keep all these notations in your brain. Like what I am saying is, the entities are represented by rectangular boxes. Inside that we will write the name of the entity, and the properties of the entity or the attributes are represented by some oval shape like this, and inside that you have to write the name of the attribute. If it is a multi-valued attribute, represent it using double oval. If it is a derived attribute, represent it using that dotted oval. Okay, so something like that, dashed oval, like that I can call. If it is a key attribute, inside the oval write the name and put an underline below it. Okay, and the attribute are connected to the entity by means of just straight line. That's all. So this is what we see. So here you can see an example. The car entity, as it is an entity, is represented by a rectangular box. Then in oval shape we have year of introduction, and what about the make, what about the model, what about the color? You know, color is multi-valued, that's why double oval we are using. Then key attribute, registration vehicle, both are keys. Registration itself is a composite attribute also, something like that. And if you are looking at this registration, like some number will be there, some and the state, vehicle ID will be there, and make in the sense Ford, like that. Okay, so then model, this particular model, and the year of the car and its color. So like this you can represent different, so car 1, car 2, car 3, these are all different entities of the entity type car. Okay, so the notations are clear. Now we will see these things, how these things are related, and relation those things we will discuss in the upcoming videos. Yeah, thanks for watching.